Okay, the next section is 10.1. We're going to do limits and motion. We'll do average velocity, instantaneous velocity, and we'll look at limits. We'll draw the connection to tangent lines and the derivative. So first off, average velocity is the change in position divided by the change in time. So on a graph, we will find average velocity, for example, and that's just going to be the total distance change divided by the total time between 2 points. So that's the average rate of change right here. It's just slope. It's just y2 minus y1 divided by x2 minus x1, which is the same exact thing that this is saying right here. So to find the derivative, what we're going to do is we're going to take the limit as x approaches the value that we're looking for the derivative at, and that is taking the limit of the slope formula. So here's the definition of derivative right here. I can quickly show you where this comes from. It's not hard. Like I just showed you, it's from slope. So let's say we have a point here which is x, f of x, and let's say we have a point here which is x. We're going to add some amount, so let's add h, and then this is going to be f of x plus h. And so when we do slope, we get f of x plus h, y2 minus y1, all divided by x2 minus x1. This simplifies because this x cancels with this x, and so we just get h in the bottom. And then if we take the limit as h approaches 0, or in other words, as this point gets closer to the other one, we'll get the slope of the tangent line, which is the derivative, which is the instantaneous rate of change. So this is the definition of derivative right here that we're going to use to find the derivative. So let's just do this example right here. The definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So f of x plus h in this case is going to be 2 times x plus h plus 4 minus f of x, which is 2x plus 4. I need to put that in parentheses. Make sure the negative gets distributed to both. Now I want to take the limit of that as h approaches 0. So you're always going to have to do some algebra to simplify first. So I'm going to distribute the 2. You get 2x plus 2h plus 4 minus 2x minus 4 all over h. Some of these things cancel. So the 2x and the negative 2x, the 4 and the negative 4, and I just get 2h over h, which the h's cancel, so I just get 2. So the limit of this as h approaches 0 of 2 is still 2. So my answer is 2 for the derivative. So it doesn't matter what point I plug in. It doesn't matter that I plug in 3. The derivative of this thing, 2x plus 4, is 2. And it kind of makes sense because what the derivative is the instantaneous rate of change, or the slope. So if you look at a graph of this thing has a y-intercept of 4, and it's got a slope of 2. It's got a constant slope. So at 3, for example, 1, 2, 3, it's still going to have a tangent line, or it's still going to have a slope of 2. Okay? So the other thing I can show you is the power rule real quick. The power rule is pretty easily done by just multiplying the exponent by the coefficient, in which case this is 2. Then you lower the exponent to 0, so it's 2x to the 0th. And then the 4 drops out. Constants always drop out because it's really 4x to the 0, so when you multiply the exponent down, it becomes 0. So I don't have to write that. And I don't have to write x to the 0th either because that's 1. So the power rule is a really easy way to get the derivative of the function. So there's the derivative of the function, which means that the derivative at any point is going to be 2. We'll just do one more easy one and we'll start the homework. So we'll use the definition of derivative again. Limit as h approaches 0 of f of x plus h minus f of x all over h. So in this case, f of x plus h would be 2x plus h squared minus 2x squared all over h. And we still need to take the limit. All right, so I'm going to FOIL this out and simplify. This turns into x plus 2xh plus h squared, but I still have to distribute the 2. So all I did was FOIL out the x plus h squared. All right, now when I distribute the 2, I'm just going to do this right here. This turns into 2x. This turns into 4 xh, and this is 2x, or 2h squared. Now, sorry, this is 2x squared. These cancel, and I'm left with 4xh plus 2h squared all over h. All right, now I can factor out an h, and I get h times 4x plus 2h, all divided by h. Now the h's cancel, and I'm taking the limit as h approaches 0 of 4x plus 2h. So as I evaluate that limit, this goes to 0, and I just get 4x as my answer. So my derivative is just 4x, and I can write that as f prime of x equals 4x. There's my derivative, and if they want, I can find the derivative at any point now by just plugging in that point. So once again, the power rule is a much easier way to check your answer. All you have to do is multiply down the exponent times the coefficient, which gives you 4. Then you lower the exponent, so it'll be 4x to the first, and that's your answer for the derivative. So the power rule is a good way to check it, but make sure that you are able to show your work in the event that I ask you to do the definition of derivative on the test. All right, let's try the homework and see if we can make this make sense.